This view shows an outcrop on the western edge of Erebus crater. From this vicinity at the northern end of the outcrop, layered rocks are observed in the crater wall, which is about 3.3 feet thick. The view also shows rocks disrupted by the crater forming impact event and subjected to erosion over time. To the left of the outcrop, a flat, thin layer of spherules-rich soils overlies more outcrop materials. The outcrop is approximately 82 feet in length. Scientists have been monitoring this so-called happy face crater in the south polar region of Mars for almost a decade. Images taken throughout the years at roughly the same seasons have shown color variations that are due to different amounts of bright frost over darker red ground. The blobby features in the polar cap are due to the sun sublimating away the carbon dioxide into these round patterns. You can see how 9 years of this thermal erosion have made the mouth of the face larger. The nose consisted of two circular depressions in the past, and now those two depressions have grown larger and merged. Measuring these changes throughout the Martian year helps scientists understand the annual deposition and removal of polar frost, and monitoring these sites over long periods also helps understand longer-term climate trends on the red planet. The panorama here was taken by the mast camera on NASA's Curiosity Mars rover. The rover's last drill at the location is visible at the far left bottom of the image, and also visible is the clay region the rover spent exploring. Seen here is one of the two wind sensors springing out of the mast on NASA's Perseverance Mars rover. These sensors are part of the Mars Environmental Dynamics Analyzer, also known as MEDA, the rover's set of weather instrumentation. MEDA was provided to NASA by Centro de Astrobiología at the Instituto Nacional de Tecnología Aeroespacial in Madrid, Spain. A key objective of Perseverance's mission on Mars is astrobiology, including the search for signs of ancient microbial life. The rover will characterize the planet's geology and past climate, pave the way for human exploration of the red planet, and be the first mission to collect and cache Martian rock and dust samples. Subsequent missions, currently under consideration by NASA in cooperation with the European Space Agency, would send spacecraft to Mars to collect these samples from the surface and return them to Earth for in-depth analysis. Curiosity rover took this amazing panorama which shows a view of Mars at sunset. In the image, we can see what the Martian terrain looks like at sunset and also a delicate halo just above the sun in the sky. This is Opportunity rover at the edge of Erebus crater on Mars, and the view provides a true-to-scale overhead view of the rover deck and nearby surrounding terrain. The view here shows outcrop rocks, sand dunes and other features out to a distance of about 82 feet from the rover. Opportunity examined targets on the outcrop called rim rock in front of the rover, testing the mobility and operation of Opportunity's robotic arm. The view also shows examples of the dunes and ripples that Opportunity had been crossing at the time as the rover drove on the Meridiani Plains. This view of Victoria Crater looks southeast from Duck Bay towards the promontory called Cabo Frio. The small crater in the right foreground, informally known as Sputnik, is about 65 feet away from the Mars rover, and the tip of the layered Cabo Frio promontory itself is about 650 feet away from the rover. The exposed rock layers are about 50 feet tall. This stunning panorama was taken during the winter season on Mars's southern hemisphere. This is the time of year when Mars is farthest from the Sun, so there is much less dust storm and dust devil activity than at other times of the year. The panorama reveals a tremendous amount of detail in the location around a small hill. Many dark, porous textured volcanic rocks can be seen around the rover, including many on the hill. Two rocks to the right of center, brighter and smoother looking in this image, are thought to be meteorites. On the right are Husband Hill on the horizon, rippled sand dune field near the base of that hill, and lighter toned home plate below the dunes. Left of center, tracks and a trench dug by the rover's right front wheel have exposed bright underlying material. This bright material is evidence of sulfur-rich salty minerals in the subsurface, which may provide clues about the watery past of this part of Gusev crater. In addition to acquiring this spectacular panorama, the rover team also acquired significant new assessments of the elemental chemistry and mineralogy of rocks and soil targets within reach of the rover's arm. The team then drove to a nearby spot on the hill to access different rock and soil samples. Scientists believe this remnant of a fan-shaped deposit of sediments known as a delta is what remains of the confluence between an ancient river and a lake at Mars's Jezero crater. The delta remnant is the raised area of dark brown rock in the middle ground of this image, which was taken by Perseverance rover. The delta remnant is about 1.4 miles to the west of the Perseverance's landing site, and the visible portion of the remnant is about 660 feet across. In the foreground is a boulder about 6 feet across that is about 425 feet from the rover. This panorama shows a field of cobbles nestled among wind-driven sand ripples that are about 8 inches high. As NASA's Mars rover continued to traverse from Erebus crater toward Victoria crater, the rover navigated along exposures of bedrock between large wind-blown ripples. Along the way, scientists studied fields of cobbles that sometimes appear on trough floors between ripples. They have also been studying the banding patterns seen in large ripples. The origin of cobble fields like this one is unknown. The cobbles may be a lag of coarser material left behind from one or more soil deposits whose finer particles have blown away. The cobbles may also be eroded fragments of meteoritic material, secondary ejecta of Mars rock thrown here from craters elsewhere on the surface, weathering remnants of locally derived bedrock, or a mixture of these. This high-rise image shows dunes and gullies on the surface of Mars. Gullies are relatively common features in the steep slopes of crater walls, possibly formed by dry debris flows, movement of carbon dioxide frost, or perhaps the melting of ground ice. Seen here is a section of crater wall from the rocky crater rim at the top of the image down to the dark, dusty dunes on the crater floor in the bottom. The rock of the crater walls shows up deep orange, and the sandy deposits on the crater floor and the base of the crater walls appear blue. The gullies in this image have two main sections, a scalloped alcove at the top of the gully and the defined channel sections further down the crater wall. Material from the alcove will have traveled down the channel to the crater floor. This normally forms a third section to a typical gully, a debris fan. Fans commonly visible at the base of gullies are not obvious in this example, however, as the wind-blown sediments have covered the crater floor after gully formation. This interesting hill area on the western rim of Endeavour crater is where many clay minerals have been detected from the orbit. In the image, we can see two of the features that were investigated by Mars rover. Copper Cliff, the dark outcrop in the left center of the image, and Whitewater Lake, the bright outcrop on the far right.